Welcome to AIML campus. Today we are going to talk about functions and recursion. So, to start off with, why do we need functions? The need of a function is to make a small part of the code different from the rest of it so that we can call that small part of the code again and again without needing to the write that same amount of code multiple times. So, if you want to create a function, let's say this is a function known as greet. When we want to normally greet someone, we do a statement of print hello, the name, and hello, this is the magical world of Python. Now we want to greet multiple peoples, then we have to like print that multiple the print statement multiple times. To solve that problem, we have created a function by using the def keyword. We use def, the name of the function, and then parameters. And in between those parameters, we enter the name which we are using in the function. After adding the name, we are going to close it and then put an indentation and then write the part which should be executed when the function is called. So over here we are using print and then hello, welcome to the magical world of Python. Then we are going to call that function. So over here we have called the function great Elsa. Now we can also create make and put it as great and name something like Bob. Now, when we run it, instead of only printing Elsa, it will also gonna print for Bob. And we don't have to write the whole print statement again and again, m- making it very easier to to write a large part of the code one time and using it at multiple places. Now, the indentation part is known as function body, and the name of the function is what we write after writing def. Def is used as define and then the function name parentheses, and inside those parentheses the stuff we take, the parameters, the constraints we take and use inside the function. Now to run to like call the function, we can just name that function, like the name of the function over here is greet, and put a parenthesis and feed which like the stuff we wanted to use. Over here we wanted to use the name, thus we have given it a string name. We can also run a function without anything uh, inside it, like we can just eliminate the name part over here and eliminate this too, and that's it. We can call read function without anything going inside it. Now, you might be wondering, so what if I want to get a result out of it? Like, I don't want to print something, I want to get an answer from it. So how do I do it? Do it. So over here we have a function known as add. It takes two parameters, a and b, and returns a plus b. So over here we have a result variable which will gonna store the output we get from add function. So over here we have given it the parameters 3 and 5. It will gonna take those and return 3 plus 5, as we can see over here. And when we get the value of 3 plus 5, which will gonna be 8, we get the value of 8 stored in result, and then we can just print it. Now, by using this curly parenthesis, we can also execute the function. So instead of doing result, we can do is add 3 comma 2 and then run it, and thus getting the answer 5. Now we are going to go for the most important part, which is recursion. Now, as far we have studied functions, function can be used to store a part of code and used anywhere. But recursion is used by using functions to solve a problem which is solved by using that function again and again multiple times. It's like a smaller version of using a for loop, but more complex. since it goes as now we have a problem of finding a factorial. Imagine we have to find a factorial. Now we can use a for loop, but instead of using for loop, we can do it more efficiently by using a function. So over here we have created a for a function of factorial, and then we have taken a number, like the number of which we want to do a factorial of. So as you can see, we want to get the factorial of 5. So to explain you what a factorial is basically the sum of 1 to the nth number. So if you want to get the factorial of 3, we take 1 into 2 into 3. Thus, it will gonna be 2 into 3, which is 6, and 3 into 6 into 1, which will gonna be 6. Thus, the factorial of 3 would be 6. So similarly, when we have to get the factorial of 5, we call a function. First, if the value of n is equal to 1, we just return the value of factorial as 1. Now, if the after that when it is 1, it will go for the else condition. Now, that's where our recursive case takes place. When n is greater than 1, then it will gonna return n into the factorial. So when the whole factorial function starts, it will gonna first check the value with 5. Obviously 5 is not equal to 1. It will gonna go for the else part. Then it will gonna go in n into, which will gonna be 5 into factorial, which will be n minus 1. Thus 5 minus 1, which is 4. Then it will gonna go again and see if it is equal to 1. It's not, thus it will gonna go for the else part. Then it will gonna multiply by n, which is gonna be 4 into factorial, which will gonna be n minus 1 again, and thus it will gonna continue till it's 1. Thus when the we get the answer, it will gonna be something like 5 into 4 into 3 into 1, giving us a value of 120. It is used for many problems such as Fibonacci sequence and many more. Over here we have also used Fibonacci sequence, but instead of using recursive function, we have used for loop. So it's possible to solve a recursive function with a for loop, but it kind of gets complicated. That's why we use recursive functions to make it easier for to understand and use it more efficiently, since functions can be used multiple on multiple places instead of using a single for loop. So over here we have done the same thing. We have start a for loop from 2, and the base condition would be n plus 1, because we want to find the Fibonacci sequence of till that number, meaning n plus 1. After that, the base case for A and B would be 0 and 1, since as you can see in Fibonacci sequence, the starting values are always 0 and 1. So after 0 and 1, the value of A and B will be A will be B and B will be A plus B. So as you can see, in the first iteration it will be like this, in second it will gonna be increased, and thus we will get the value of Fibonacci sequence. And for the 18th place, it will gonna be 55. Now, what we are gonna do is escape the for loop early with the powerful spell called break. We have explained this in the previous video, but I will gonna explain it again. We can escape for loops by using break statements. We use break statements to come out of a for loop. For example, if we want to execute a code and we want to break after we find something, we use the break keyword. So as you can see over here, we have used break as soon as we found the slow. Similarly, there is continue statement which we use to continue when we found something which we don't want to register, or something which we want to skip over. So if imagine if there is a line and we want to break out of that line because we have a call or something, then we use the break statement. But if we want to skip that line, we use this continue statement. Now we can see over here that using the for loop, we can do the sum of number. We can also do the same thing using the recursion too. Now, as the end of the video, we are going to solve a very popular question known as Tower of Haino. This problem consists of three disks placed in a single tower, and there are three towers. One of them is an auxiliary tower, meaning it is used to solve the problem, and then there is the destination tower, which is the place where we want all three of the disks to be placed on. But to move those disks, there are some conditions. The first condition is only one disk can be moved at a time, meaning we can't move more than one disk in one turn. Second is a disk can only be placed on top of a larger disk or an empty rod. So we can't place uh, the first orange disk over here, then we can place the blue disk over here. We can only place the blue disk, and on top of that we can place the orange disk. Now the third is condition is all disk at starts on the first rod. So everything will be on the source rod, then it will gonna move from this to auxiliary, then destination. This problem can be easily solved using recursion, and that's what we are gonna do over here. So recursion, as I've told you, is the method of calling a function in a function itself, which is happening over here. Over here we have function tower of Haino, and we call it again over here when the conditions are met, which is a else state. Now, to start off with, first we will gonna visualize how the Tower of Hainu works. So, to store everything from source disk to destination, we are gonna first re- take the orange disk and put it in destination. Then we are gonna take the blue one and put it in auxiliary. Then we will gonna take the orange disk from destination to auxiliary and then put the source disk in destination. We are gonna put the auxiliary disk, which is orange, to the source, and then we will put the blue disk from auxiliary to destination. After that, we will gonna move the orange disk from source to destination, thus solving the problem of Tower of Menu. To put it in code, we will first write the a function move, which will gonna move disk A to B. Then we have um tower of Hainu, which will gonna be the main function. Over here we have multiple things such as N, A, B, and C. A, B, and C being the name of the towers. And over here we start off with if N is equal to 1, move A to C, meaning the value of if there is only one disk remaining, we are going to move it from A to C, C being the destination node and A being the source node. Now, if that condition is not met, what we are going to do is move those disks to other places and get only one disk to move it to the destination. So over here, what we are going to do is we are going to take tower of Henu, we are going to call it recursively by decreasing it by 1, and we will take A, C, and B, meaning we will gonna change the destination node from auxiliary node. Thus, when it's gonna run, it will gonna move from it will gonna check if the conditions are met and thus move it from A to C. After that, when this function is completed, we are gonna move A to C, and then we are gonna call it again by calling changing the source node to B, A auxiliary node to A, which was our previous source node, and destination node will be C. Now, to do this, when we complete the execution of this code, we get something like this. A to C. We will gonna move the disk A to C over here. Then we have moved disk A to B, so blue disk will gonna go to auxiliary. Then we will have C to B, meaning the C disk will gonna go to B, meaning this disk will gonna go back on top. Now A to C, meaning the last one will gonna go to C. After that, we are gonna do is we are gonna put the orange disk over here, and then we are gonna take the blue one on the destination, and after that, the orange one will gonna go back to C. As you can see, A to C. That's it for today's video. Make sure to understand that functions and recursion are very important concepts in Python, AML, and well, a lot more. These are basic foundations which help in understanding how a program runs and executes.